Hello dear students, this is Jayant Mane from Phenolux Academy Ratnagiri. This is the third lecture on choice of electrical drive. So the points are written here. We'll see one by one. So the very first point is steady state requirements. So when we are choosing drive for some application, in that case the steady state requirements is very important. So those requirements could be the nature of torque and speed regulation. Speed regulation is the change in the speed from its initial value. As the load changes, sometimes the speed also changes. It is very small change, but still it changes. So that is the speed regulation. Efficiency of operation. What is the duty of the drive? Duty means whether the drive is continuously running, means for hours or for days continuously 24/7. That is continuous duty, or it could be a short time duty, means it is running for few minutes or up to 1.5 hours, 90 minutes. Or sometimes it is intermittent duty, means starting, then operating, then stopping, again starting, operating and stopping. Meanwhile there could be rest. So like that, duty of operation. Then what are the ratings needed by the load, and the fluctuations allowed. So these are some steady state requirements. So what is the nature of the speed you need, nature of the torque you need? Means a constant torque machine or variable torque machine, constant speed machine, variable speed machine. Then it's speed regulation, whether allowed, or if it is allowed, then how much is that. Efficiency, how much you want. And duty of operation, ratings required, and fluctuations. Then the second point is transient operation requirements. So in the last lecture I have already told you that steady state requirements. Steady state means when torque and speed both are constant. In that case the drive is called a steady state. And transient means when the speed is changing or torque is changing, so that is transient operation. So here the transient operations are given: acceleration, deceleration, starting and braking, speed reversing. So all these are transient operation requirements. So what is the acceleration you want? Means in how much time you want some particular change in the speed. Similarly, deceleration, reduction in the speed in some time. Starting, so how much is the starting time? How rapidly you can just reach to your final speed from zero speed, that is starting. And braking requirements, so whether you want any electrical braking or not. Again, in that electrical braking there are three types of brakings. Out of that, which one you would be preferring, or you just want to go to just mechanical braking. And again, speed reversing, whether you want speed reversal or not. So that is also important parameter. So these are some requirements. Then another, source requirements. So from source point of view, voltage fluctuations, whether it is allowed, and if it is allowed, then what could be the voltage fluctuation, its magnitude, how much voltage is required. And in case of AC drives, power factor is very important. So voltage fluctuations, whether they are allowed or not. If allowed, how much is the quantity, magnitude of the voltage, And power factor. Now, why power factor is important, that you might be knowing. If there is some considerable amount of power factor, in that case reactive power requirement is high, and the reactive power is a power which uh, is getting stored into the different circuit elements, inductors and capacitors. It is just getting stored, it is not doing any useful work. Useful work is done by only active power, and reactive power is getting stored into the line capacitance, suppose, or any stray capacitance is there, any line inductance is there for high frequencies, so all of that. So reactive power has to be reduced. So there are some nowadays advanced drives which maintains power factor at almost any operating point. Otherwise, generally you know that in industries power factor is being managed by some capacitor banks, and they are switched in and out according to the loads uh, loads in the machine, in the industry. But they are not regulating the power factor smoothly. They can be changed in just few steps, so it is not precise correction of power factor. So there are some drives which are having inherent power factor controlling capability. So that also you have to see. Obviously, if any drive is having such function inbuilt, in that case its cost is high. In case of maintenance and all that, it is not very easy, and so many things you have to consider. Then very important, capital cost. Capital cost is very important. So someone may be saying that, okay, I am setting up some industry, and okay, whatever is the technologically most advanced drives, that I will install in my industry, like that. Sometimes it may not be feasible, because very advanced drives means they might be very costly. So what is the capital amount you are having, and what is the maintenance cost? So always it is some trade-off. Generally good quality machines, drives are costlier, they are having good amount of capital cost involved, but they may be requiring no maintenance at all. So that trade-off, the you can say design engineer has to take care. So this is also one of the point while selecting the drive. Then again, very important, reliability. Now reliability is how much we can rely on the drive, means in any condition it will be running, any number of times we can start it, stop it, like that. So just consider any, suppose, medical application, or any aviation application, marine application, or um, some, you can say, some space project or anything like that. If such are the applications, in that case the reliability is the highest concern. Cost is not the highest concern. Suppose anything happens to the drive in while plane is flying in the air, or during the any space mission, in that case it cannot be reversed instantly, it cannot be repaired instantly. So in that case reliability is very important. So at any time, in any condition, it should deliver the required amount of performance. That is what the reliability is. So we have, how much we want reliability. So that is what the issue, that point you have to consider while selecting the drive. And the restrictions, what are the restrictions on speed, torque, loading? So every drive, every motor is having some overload capacity, but obviously it depends upon design. So generally they are designed for double loading for short time, very short time, but some specially designed drives could be loaded up to 6 times than the rated. So obviously the loading time is very small, but they can be loaded up to 6 times than the rated, and in that case also they deliver the performance. So those are restrictions you have to consider. And the last point is environment and location. How is the environment of drive while it is in operation? Means it could be a radioactive environment, it could be explosive environment, or humid atmosphere. Drive could be, you can say, submerged into the liquids, like that. So suppose there is some oil refinery and the drive is used to pump the crude oil from the bottom of the sea. In that case, the pump is obviously submerged into the sea. If it is some nuclear power plant, in that case radioactivity is there. Again, in oil industries and all that, it is explosive. Some gas industries, oil industries, some explosive environment could be there. In that case, suppose DC motors are used, there is always sparking in between commutator and brush. So that cannot be, you can say, allowed. So just somebody is looking at some performance of the drive, and if it is not, he is not considering the environment in which the drive is going to be installed, uh, that is that would be a wrong selection of the drive. So environment has to be considered, and the location. So just like I told you that submerged into liquids or any radioactive environment, or what about it? What are the locations? Sometimes the drives could be vertically mounted, motors could be vertically mounted, horizontally mounted. Mostly we mount motors horizontally, but there could be some applications where there is no room for mounting it horizontal, or the requirement of the system is not like that, and you have to mount the motor vertically. So how is the location? That is also important. So all these points one should consider while selecting a drive.